Hi students, now we are going to look at a derivation based on refraction at spherical surfaces, right? So for that we are going to take a convex lens. So just a part of a spherical surface of that convex lens, right? So if this is the convex surface and if this is the pole, that is a pole of the convex surface, right? And this is the principal axis passing through the pole. O be the object kept on the principal axis. Now let us take this as the refractive index 1 because it is a rarer medium, and the lens as another medium, so it is denser one, right? So let us take that medium as mu2, right? The light ray passes through like this, so at the pole it will be straightly passing, right? We know that because whenever light ray falls on any convex or concave surface normal to it or at right angles to the surface, certainly it will be retraced. But here, whenever light ray passes through the pole or optic center of the lens, whether it is convex or concave, it passes straightly without any deviation, right? Now, a light ray from the object incident on the refracting surface right of the convex lens. Let me take that point as a D, right? I mean, let me so this point as D, and here C is the center of curvature for this convex lens, and after refraction, this light ray incident on the refracting surface at this point D, and after refraction, the image will be obtained at a point right I. Okay. Now, on the point D, I am going to draw a normal. Normal to the surface, and then I am extending it so that it's meet the point at C. Now here, mark this point as the angle of incidence, and mark the point here as the angle of refraction, and we got to mark some angles. Here the angle DOP is taken as alpha, the angle DPC or DPI is taken as the angle DCP is taken as beta, and the angle DCI, here this angle, is taken as some gamma. Here, how three triangles are formed? See, I said when this light ray from this object O incident at the point D, it has fallen or incident at this point D just closer to the point P. So it should be assumed that the light ray has fallen closer or incident closer to the point P, so that this DP should look like a straight line. For example, if the light ray would have fallen at this point, certainly if this is D means this line looks like a straight line, right? Like that, it has incident closer to the point P, so DP should look like a straight line. So this is a triangle, this is another triangle, and this is another triangle, like that we are considering, right? Now, in triangle DPO, I am going to take tan alpha So tan alpha is nothing but opposite by adjacent, that is dp by pu. Since all the angles here, alpha, beta, gamma, r, gamma, I, everything are smaller angles. So this tan alpha becomes alpha dp by pu, right? And tan beta, so dp. So if I take this triangle dpc, right? So it becomes tan beta is equal to dp by pc, or beta is equal to dp by pc. If I take another tan gamma for the triangle, so dpi, so dp by pi, so which is equal to gamma. So tan gamma, since the angle is small, gamma is equal to dp by pi. Okay. Now let me find out the values for the I and R. So if I take a triangle that is DPC, right? So in triangle D, that is DOC. Okay. Now I is nothing but alpha plus beta, and in triangle DCI, right, angle beta is equal to R plus gamma, or R is equal to beta minus gamma, right? Now I am going to find out some equation using Snell's law. So you know Snell's law, 1 mu 2, that is, it means refractive index of the second medium with respect to first medium, which is nothing but sin I by sin R. Since the angles are small, I can write it as I by R. Here 1 mu 2 can be written as mu 2 by mu 1 is equal to I by R. So cross multiplying, mu 2 R is equal to mu 1 I. So let me substitute the values of R and I here. So mu 2 R is nothing but beta minus gamma, mu 1 I is nothing but alpha plus beta. So let me expand this. Mu 2 beta minus mu 2 gamma is equal to mu 1 alpha plus mu 1 beta. So if I bring this mu 1 beta here, mu 2 beta minus mu 1 beta is equal to mu 1 alpha plus mu 2 gamma, right? So let me wrap this. So we need these values here. So taking B, that is beta commonly outside, and let me substitute the values of beta, alpha, gamma from here. So beta is nothing but dp by pc, mu 1, alpha is nothing but dp by po, plus mu 2, gamma is nothing but dp by pi. So here when the distance is taken along the direction of the light ray, it will be positive. It will be positive, right? The value will be positive. So PC is nothing but the radius of curvature which is taken along the direction of light ray, right? So it is plus R. Pi is the image distance and which is taken along the direction of light ray. So Pi is equal to V. So Pi is equal to V plus V. PC is equal to plus R, the radius of curvature. And what is PO? See, this PO is taken opposite to the direction of the light ray. So PO is equal to minus U, which is the object distance. So here, when I take the dP on the right hand side commonly outside, this dP and this dP will be cancelling. Right? So mu2 minus mu1 by what is PCR is equal to mu1. What is PO? PO is nothing but minus U. Minus U plus mu2. What is Pi? That is V. So mu2 by V minus mu1 by U is equal to mu2 minus mu1. This is the general equation for the refraction at spherical surfaces. I think we have understood. Thank you.